Welcome back. Most students are familiar with the fundamental theorem of calculus. They don't always think about how this can be applied in a contextual situation. Our basic fundamental theorem of calculus is usually written in this form. In a contextual problem, if we integrate a rate of change, what we're going to get is the amount of change that has taken place in the function. This is the amount of change in f of x between x equals a and x equals b. A useful variation on the fundamental theorem of calculus would be to add this term to the other side. So it could be written like this. This is particularly useful in certain application problems, where f of a represents an initial amount plus, remember that this integral represents the change in the amount. And so if I take my initial amount and add up how much has changed in the amount, what we're going to get is a new amount. Let's look at a couple of example problems. In my first example problem, what we have given is a rate of change in the number of mosquitoes on Tropical Island. Our task is to find the number of mosquitoes on the island at time t equals 14 days. Many students think, well, if you integrate the rate at which the population is changing, that you'll get the population. And that's not correct. If you were to integrate from 0 to 14, r of t dt, you're going to get the change in the mosquito population, but you won't get the new mosquito population. In order to get the new mosquito population, you need to start off with your initial amount of mosquitoes, which is 1,000, and then plus add the amount of change that has taken place in the mosquito population, and this should give us the population of mosquitoes on day number 14. Let me pick up my calculator. And I've already entered this, as you can see. I've got the initial population of 1,000 mosquitoes, plus I'm integrating the rate of change from 0 to 14. It'll just take a moment to do this mathematics here. And so I'm getting a population of 982.259. I normally round to 3 decimal places, but it doesn't make sense to have a fractional part of mosquito. So I'm going to say that we have 982 mosquitoes on the 14th day. That is my mosquito population. Let's look at a second example. In this next example, we have two rates that interact with each other. We have the rate at which sand is being added to sand is being removed from a beach by the tide, and then we also have the rate at which sand is being added to the beach by a pumping station. Our task is to find the amount of sand on the beach after 6 hours. Again, many students think if you integrate these rates, you'll be getting the amount of sand. So they would integrate from 0 to 6, and we have sand that's being added, so that's positive, minus, we've got it being removed, so I'm going to subtract. And remember, this is not going to give me the amount of sand on the beach. It gives me the change in the amount of sand on the beach. In order to determine the amount of sand on the beach, I'm going to have to add in this initial value of 2,500 cubic yards of sand. That's the piece of information that many students leave out. Okay, I'm again picking up my calculator, and I've already entered the integral. It's just a matter of us hitting enter. And I'm getting 2,493.27667 cubic yards of sand. Let me see if I can round this off correctly. Remember, on the AP exam, they'll take your answers rounded or truncated to 3 decimal places, or you could give more than 3 decimal places. I need to make sure that I include appropriate units. So this is cubic yards of sand. And notice that this is the amount of sand that is on the beach after 6 hours have gone by. Thanks for listening and enjoy calculus.